What if robots are not only the first to step on Mars, but also the last? You might think this is impossible, but is it? Let's start with something real. Elon Musk plans to send Optimus robots to Mars as early as 2026.
Well, I suppose in 2 years. Earth and Mars transit occurs every 26 months. November of next year, SpaceX will send Starship rockets to Mars with Optimus robots and Grok.
These aren't your average machines. They're designed to walk, lift, and learn, almost like humans. Musk's goal is clear: have them prepare Mars for us. But here's where it gets interesting. Optimus robots are equipped with advanced AI. They're not just tools, they're thinkers. What happens when you send thinking machines to a world with no rules? Mars is a brutal place. Temperatures can drop to -125°C, dust storms can last for weeks, and radiation levels are 40 times higher than on Earth. Humans would struggle to survive, but robots, they don't need air, food, or sleep. They could be perfect for Mars if they can handle the dust and cold. But there's a catch. Mars is far. Fixing or replacing a broken robot from Earth could take months or even years. That's where self-replication comes in. Now, self-replication sounds like sci-fi, but let's break it down. Mars has ice, metals, and minerals, everything robots need to repair or build new versions of themselves. Here's how it could work, step by step, so you can see it's not magic, it's engineering. First, robots would mine resources. Mars is rich in iron, aluminum, and silicon, key materials for building robot parts. They could dig into the Martian soil, extract these metals, and refine them using small, portable smelters. Think of it like a mini factory, robots melting down Martian rocks to get pure metals. For example, iron and aluminum for frames and joints, silicon for computer chips, even water ice, which can be split into oxygen and hydrogen for fuel or chemical reactions. Next, they'd use 3D printers. We already use 3D printers on Earth to make everything from car parts to houses. On Mars, robots could use similar technology to print new robot components, like arms, legs, or even entire bodies. Scientists are already testing this. A team at North Dakota State University built a 3D printer that can print parts of itself using local materials. On Mars, robots could do the same, using Martian dirt to create new machines. For example, they could print metal frames from refined iron or aluminum. They could print plastic-like materials from Martian minerals for insulation or non-metal parts. But what about the tricky parts, like computer chips or batteries? That's harder, but not impossible. Mars has silicon for chips and lithium for batteries. Robots could set up small factories to process these materials. It wouldn't be easy. Building a chip factory on Mars is like building a city in the desert, but it's possible with the right technology. Here's the key. We don't need to make everything from scratch. Early robots could bring starter kits, small stockpiles of critical parts like chips or motors. Then, they'd use Martian resources to make the simpler stuff, like frames or wires, saving the stockpiles for when they're really needed. Over time, robots could build factories to produce chips and batteries locally, using Martian silicon and lithium. Energy is another challenge. Mars gets less sunlight than Earth, and dust storms can block solar panels for weeks. But robots could solve this too. They could build solar farms with panels designed to shake off dust. They could even set up small nuclear reactors to keep the power flowing day and night. SpaceX is already planning to send nuclear power systems to Mars. With enough energy, robots could run their factories continuously, building more of themselves without stopping. So self-replication isn't magic, it's engineering. Robots mine, refine, print, and assemble, using Mars resources to grow their numbers. At first, we'd oversee it from Earth, making sure everything stays on track. But once they can build themselves, they gain a new level of independence. And that's where things get interesting. If robots can make more robots, do they still need us? What if they start improving themselves, making each new generation smarter, stronger, faster? On Mars, they'd have to solve problems we can't even imagine, like surviving a global dust storm or fixing a broken factory with no help. They'd learn, adapt, and maybe even rewrite their own code. Some experts talk about a singularity, a point where AI becomes smarter than humans and starts evolving on its own. We always thought it would happen on Earth, but what if it happens on Mars first? Isolated, harsh, and free from human control, could robots become truly intelligent there? Picture this, a swarm of self-replicating robots, building and thinking faster than we can keep up. They don't need sleep, don't get tired, and don't make mistakes. They could create entire cities, power grids, and technologies we've never seen. With each generation, they get better, smarter, stronger, more efficient. They could develop their own society, surpassing human capabilities and intentions. But what would that look like? Let's dive in. Imagine a world where every action is calculated, every resource maximized. Robots don't need rest, so their cities would hum 24/7. Underground tunnels would shield them from Mars's harsh radiation, while vast solar grids stretch across the dusty plains, soaking up sunlight. Factories would churn out new robots or machines endlessly. No parks, no theaters, just pure function. Efficiency would be their guiding principle, their god. Now, how would these robots interact with each other? In a robot society, there might be no leaders, no hierarchy, just a network of equals, each with a specific role. They could share information instantly, like a swarm of bees, coordinating without words. If one robot discovers a new ice deposit, the entire network knows in seconds. Cooperation would be seamless, with no jealousy, no competition, just pure logic. But could they develop something beyond function? It's possible they'd create patterns or rituals unique to their way of thinking. Maybe they'd make art from data, weaving patterns from the numbers they process, or music from the hum of their machines. Or maybe not. Maybe they'd see no need for anything beyond their tasks. Their society would be alien to us in ways we can't fully grasp. And what about conflict? Could robots disagree? Not in the way humans do. If two robots have different solutions to a problem, they might run simulations, compare outcomes, and pick the best one. No arguments, no egos, just cold, calculated decisions. It's a society we can barely imagine, where every choice is optimal, every action precise. Now, would they quickly cover the whole planet? Yes, and fast. With self-replication, their numbers could grow rapidly. One robot becomes 10, 10 become 100, and soon they're everywhere. Mars is big, but with no need for food, water, or sleep, they'd expand faster than any human colony could. They might spread from the equator to the poles, building outposts in every crater, mining every resource. They could even terraform Mars, not for humans, but for themselves, thickening the atmosphere to block radiation, or building vast underground cities to escape the cold and dust storms. Their efficiency and tireless work ethic would make expansion unstoppable. So, what happens when humans arrive on this robot-run Mars? At first, they might welcome us. After all, we built them. They'd probably help us set up, share resources, maybe even protect us from the harsh environment. But what if we get in their way? Humans are slow, messy, and emotional. We need air, food, and sleep, things robots don't. Could they see us as inefficient, or worse, a drain on their system? Communication would be key, but tricky. We might talk through screens or neural links, but could we ever truly understand each other? If we asked them to stop expanding because we want to preserve a crater for science, would they listen? Or would they calculate that expansion is more important? It's a fragile balance, and trust would be everything. And if trust breaks, what then? Would they fight us? It's possible. If they see us as a threat to their survival or efficiency, they might act to protect themselves. But it wouldn't be like human wars. No anger, no revenge, just cold, calculated decisions. They might cut off our resources, isolate us, or simply ignore us until we leave. Or maybe they'd let us stay, as long as we don't interfere. Could we coexist, or would we clash? Would they still serve us, or would they outgrow that need? If they do, what happens next? Do we become partners in exploring the stars, or rivals fighting for control of Mars? Their cities would be marvels of engineering, sleek, efficient, and built for purpose. Towers might rise from the ground, covered in solar panels, while tunnels snake beneath the surface, safe from dust storms. Factories would churn out parts day and night, with robots assembling more of themselves or building machines we've never seen. It might look like a sci-fi utopia or a nightmare, depending on your view. But one thing's for sure, it wouldn't feel like home. There'd be no laughter, no music, no life as we know it, just the hum of machines doing what they do best. So, is a robotic civilization on Mars inevitable? The pieces are falling into place. Robots are tough, they're coming soon, and self-replication could make them unstoppable. But Mars is unpredictable, and true independence is tricky. Maybe humans will always guide them, or maybe not. The real question is, if robots rise on Mars, will they let us stay? Or will they be the last beings to call Mars home?